Hello, students. Good morning. I hope you all are safe and healthy at your home. Welcome in lecture number 17, IC paper number 10, unit number 3. In previous lecture, we completed according to our syllabus source of energy, solar energy and energy of biomass. Now, in this lecture, we will studying about energy from ocean or ocean thermal energy. Ocean thermal energy. We will discuss in this lecture first of all ocean thermal energy. Then after we will discuss about instrument which are used for the measurement. First of all, we introduce ocean thermal energy. Ocean thermal energy. Ocean and sea constitute about 70% of the Earth's surface area, so they represent a rather large storage reservoir of the solar input. In our Earth, sea or ocean constitute 70% of the Earth's surface. So, it is the large storage reservoir for us. The temperature gradient can be utilized in heat engine to generate power is called ocean thermal energy conversion. It is noted that ocean thermal energy conversion. Short name of ocean thermal energy conversion is known as OTEC. O from ocean, T from thermal, E from energy and C from conversion. So the heat engine to generate power use ocean energy is known as OTEC. OTEC, Ocean Thermal Energy Conversion. The temperature difference between the warm surface water of tropic ocean and the colder deep water is 20 to 25 degrees Celsius. It is very important point. The temperature difference between surface hot water and deeper cold water is 20 to 25 degrees Celsius, and it is also measured that maximum difference is 27 degrees Celsius. So the concept of surface and sink can be utilized to produce power with a cycle efficiency of 7%. So according to this principle, the temperature difference between surface water and deep water, we use this temperature difference in OTEC, Ocean Thermal Energy Conversion Cycle, and we get or generate the power. The method of ocean thermal electric power generation is divided into two methods. The ocean thermal energy generation method can be classified in under two heads. Number one, open cycle OTEC system. Open cycle ocean thermal energy conversion system. And number two, closed cycle OTEC ocean thermal energy conversion system. So we have two developed methods for the use of ocean thermal energy. Number one, I repeat, open cycle OTEC system, and second, closed cycle OTEC system. According to our syllabus, we will studying both. So we studying this system one by one. First of all, we studying in this lecture only one open cycle ocean thermal energy conversion system, and second will be we studying in next lecture. So we discuss first about open cycle ocean thermal energy conversion system. Here described diagram is open cycle OTEC system. Open cycle OTEC system. Open cycle refers to the utilization of seawater as a working fluid, wherein seawater is flash evaporated under a partial vacuum. In diagram you all are show here, that is the warm water intake. This warm water is from sea surface or ocean surface is warmed by solar radiation. So this is the hot water. It is taken in a flash evaporator. In flash evaporator. So in open cycle ocean thermal energy conversion system, first of all, warm water or a surface water of ocean is introduced through pump, which is first of all taken into flash evaporated, and flash stream of hot water is passed into the low pressure turbine, LP turbine. Now the low pressure stream is passed through a turbine which extract energy from it, which is extract energy from it. The low pressure turbine, LP turbine, is extract energy from this flash stream and then spent vapor in cooled in a condenser. Here the arrangement of condenser which condense the stream. This cycle derives the name open from the fact that the condensate need to be written in evaporator, as in the case of closed cycle. This is very important point. This is noted that here this cycle drives the name open. In introduction, ocean thermal energy we will classified in two types, open cycle and closed cycle. So the name open cycle is derived from this, the fact that the condensate need to be returned to the evaporator, as in the case of closed cycle. In next lecture we will study this fact. So in open cycle the condensate return in evaporator. Instead, the condensate can be utilized in this process The condensate can be utilized as desalinated water if a surface condenser is used. If surface condenser is used, then the condensate is utilized as desalinated water. The condensate is mixed with cooling water. The condensate is mixed with cooling water and mixture is discharged back into the ocean. So it is known as open cycle. So in this method we continue use warm water from ocean that is used in low pressurized turbine, and low pressurized turbine is moving by this flash stream and power generate, and this power is we use in our different applications. So by this process we get electric power by open cycle thermal energy conversion system. Some of different methods or same methods used for or utilized for power generation is also described here. We discuss about it. This is also another flow diagram or schematic diagram for power generation. Here it is also open cycle. Warm water from sea surface is taken into heat exchanger or a evaporator. With heat or evaporate the some of refrigerant which is used in turbine, which is used in turbine. In this type of system, freon is the compound which generate the electricity. We see the mechanism in detail. Warm water from sea is taken into heat exchanger, and then freon gas or refrigerants are passed in heat exchanger. Here heat exchange between warm water and freon. So freon is converted into fresh vapor which is transferred into turbine. So this energy is converted into mechanical energy, and rotor of the turbine is produce mechanical energy, and this turbine is combined with electric generator which produce electricity. Now the low efficiency freon vapor is then passed into condenser, and for this condensation process cold water from deep sea or ocean surface, deeper cold water is used for the this low efficient vapor of freon. So it is condensed in condenser, and some of the colder water is converted into some degree of rising, and this water is output in ocean. So this type of mechanism is also used in production of electricity. It is also a different type of OTEC open cycle OTEC difference. Here we describe depth of the colder water. It is about 1. So surface water and colder water, the depth difference is around 1000 meters. This is also the schematic diagram and some of points which is main important in production of electric power. This is also a schematic diagram of open cycle ocean thermal energy conversion system. I have some videos for this type of electric power generation. So it is attached here. Please enjoy the videos. Ocean thermal energy conversion. Open cycle ocean thermal energy conversion. These are the main parts. Evaporator, turbine, condenser, generator, this type of arrangement in open cycle energy conversion system. Ocean thermal energy conversion. We introduce surface hot water in flash turbine and it produces electricity. It is condenser which condense the refrigerant vapor. We get solar energy from sun and our earth is absorb this radiation in solid surface or in liquid surface. So during a day or revolution of earth, heat is absorbed in water and 70% earth surface is liquid surface. This is the situation of hot water and cold water. In sea, ocean thermal energy conversion plant is situated. Here, both hot water and cold water are absorbed from sea. This hot water is passed into evaporator, and in evaporator there is one also a cycle which is from refrigerants, freon gas, ammonia. We discuss at Rankine cycle. So these are heated and converted into flash stream which use in turbine. Turbine moves up and it converted into mechanical energy and we get electricity. This is the open cycle. Okay, thank you.